This example here, we want to try to recognize what type of quadratic this is. We have an x and a y squared, okay, and no x squared. So that means that this is going to be a parabola. Now, because it's a y squared parabola, it's a sideways parabola, or x equals y parabola. So when we do this, we could just do it like this. Okay, so we're going to go x equals 2. I'm going to factor out that coefficient. Okay, and then I'm going to factor out the 2/7 out of here. Now, a trick to factoring this out is you can divide by that coefficient. If I divide by 2/7, I end up with 7y. Okay, so I still need to complete the square here. So I'm going to take half of 7 squared is going to be 3.5 squared. It's going to be 2.25. And then I need to make sure I balance that. So I multiply 2/7 times 12.25. Okay, so I'm going to end up with 3.5. So I'm going to have to balance it with a negative 3.5 on the outside. I'm working on the same side, so I'm going to balance it with its opposite. Okay, so then once I have that, I'm going to put it into this perfect square form. And I can see where the vertex is going to be. It's going to be at -3 down or up 3.5. Remember that this is now backwards. Okay, this represents my horizontal shift. This represents my vertical shift. Now the x's are in the right direction, y's are opposite. Okay, so I better write that down before I forget. So center is going to be at -3, +3.5. Okay, just so I can make sure I see where that's coming from. That -3 comes from the x transformation, and that 3.5 comes from that 3.5 there. So then I can graph this. This is a sideways parabola. -3, 3.5, maybe somewhere around there. Okay, and it's going to be a horizontal compression. Okay, so it's going to be kind of a wide parabola because it's going to be compressed by 2/7. So that's what it kind of generally looks like. We can also, and this is not necessarily something you may want to do, but some people may be looking at this way and say, well, like with any other quadratic, I can put the x transformations with the x. So that -3 really is +3, and I can say that is a horizontal shift of left 3. Yeah, that's where I get my center. Okay, and in fact, I can also put that transformation, 7/2, onto the other side. So this is a horizontal compression of 7/2, or the reciprocal 2/7. And then we have all our x transformations with the x, or y transformations with the y's, and it works like all the other quadratics. Now, this is not necessarily something I would recommend doing because I think it's probably easier to just think backwards with the x's and y's switched with the regular parabola. However, this is consistent with how we do all the other ones, right? Everything is backwards here. Okay, so what about this one here? What's happening as I go from this function to this function? Well, the only change really is, and the main change is this -12x to -20. Well, that's our d coefficient. Our d coefficient is changing. If our d coefficient changes, really that relates to a horizontal shift. Okay, and again, it's not going to affect, there's no e coefficient or the coefficient on the y. So there's nothing going to change vertically, just horizontally. Now F1 and F2 are numbers that we don't know, so we don't need to calculate them, but they're kind of there, we don't really even need to keep track of them. The best way to figure this out is, where is the horizontal position of this one, and then compare it to the new horizontal position here. Okay, so to do that, I'm going to do my original here. So I'm going to go x squared minus 12x plus blank, okay, plus 4y squared plus f1 equals 0. And then I want to compare that to what happened here. So I'm going to do the same. I need to find the center here. X squared minus 20x plus blank plus 4y squared plus f2 equals 0. Okay, well then I'm going to complete the square here. This is going to be 36. I need to balance this with a minus 36. Okay, here I'm going to complete the square. It's going to be 100, and I need to balance this with a minus 100. Now, in the end, since we can't calculate f1 or f2, they are really irrelevant to the problem. Okay, really what's relevant to the problem is just the shifts. Okay, because that's the only thing that's going to change. Here we can't figure out what's changing because we don't really even know what f1 and f2 is. So then my next step, I'm just going to kind of ignore that part. So here I'm going to complete the square. So I know my center is at plus 6 plus dot 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 dot, right? We don't really care what's going on after that. Over here, we're going to end up with x minus 10 squared plus 4y squared. Everything else after that really we can't really use anyway, so I'm just going to go dot 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 dot. Okay, now if you want, you can just keep track of it. There's nothing wrong with that. But what's really important is, what's relevant is here to here. What's happening? I have an x equals positive 6 center here. And it's changing to an x equals positive 10 center here. So the change in x is what I'm looking for. What's the translation? The translation is going to be plus 4 to the right. Okay, so that's what I'm looking for. That's the translation. So that's the change as I change the d value from negative 12 to negative 20. It ends up being a translation of 4 to the right.